The problem for 11.2 reads, Miss Cave teaches two statistics classes, her second period class and her fourth period class. Below is a two-way table related to each of Miss Cave's statistics classes and the amount of boys and girls in each of them. The variables are independent, that is, the amount of boys and girls in each class are not dependent upon each other. The contingency table below shows how many boys and girls are in each class and the grand totals of both of them. On the lower right-hand corner is the grand total of 54 students. All right, now we have to state our hypotheses. The H0 is that the amount of boys and girls in each class are independent upon each other. And the alternative hypothesis is that the boys and girls in each statistics class are dependent upon each other. In all of these types of problems, the H0 will always be that the two variables are independent, and the alternative will always be that the variables are dependent. Here we are shown the contingency table again, and we have to find both the dimension of the matrix and the degrees of freedom. In order to find the dimension of the matrix, it is the rows by the columns. In this table, it is 2 by 2 because there are 2 rows and 2 columns. In order to find the degrees of freedom, we have to multiply the number of rows minus 1 multiplied by the columns minus 1. So in this problem, it is 2 minus 1 times 2 minus 1, equating to 1 times 1, which will result in the degrees of freedom being 1. The next matrix that you must create is the expected frequency matrix. The formula how to fill in each section of the expected matrix is the row sum multiplied by the column sum divided by the grand total. You will use this equation in each one of the squares of the matrix. The final matrix that you will have to draw out is the complementary matrix. The formula that you use to equate the complementary matrix is the observed minus expected squared divided by the expected. You will use this formula in each one of the squares in order to come up with the totals. Also, the test value is equated, and you can find that on the grand total, which is the lower right-hand box. In this problem, the test value is 1. You can also find the test value by doing the equation chi-square equals sigma multiplied by observed minus expected squared divided by the expected. Now, let the level of significance be equal to 0.05. We will work the rest of the problem out below. First, we'll draw a right-tailed graph, and the next step we must do is find the critical value. You can find the critical value by using your calculator. You go to inverse chi-square and then enter in the area to the left. In this problem, that is 0.95. Then you enter in the degrees of freedom, which we worked out earlier, which is 1. We will plot 3.85, which is what we got as the critical value on the graph. Then we must refer back to the test value, which we got, which is 1.0. We then graph that on the right-tailed graph. Since 1.0, the test value does not lie in the critical range of the critical value. It lies outside of that. We do not reject. We now have enough evidence to claim that the amount of boys and girls in each of Miss Cave's statistics classes are independent of each other.